Hello Matrix and welcome to Was a Matrix. My name is Looney and today we're focusing on your final exam prep for geography. All you need to do to send questions and comments through to us is follow Was a Matrix on all our social media platforms as well as our WhatsApp line. All of the details are on the screen. We've got a cool competition going on for you guys, so please stay tuned to get all of those details later on in the show. I've got Camelin, our awesome teacher, as well as Nicolene, our sign language interpreter. Thank you so much, guys, and over to you.
Thanks, Looney. Hi, Nicolene. Welcome back. Geography Paper 2, Geographical Skills and Techniques, Map Work. Today, we're going to focus on that sections that you've been asking for, the calculations. Let's take a look at where our focuses are for today. So, remember, from the previous lessons we've been talking to, the following were very important. Remember that no two maps are the same. And for your preparation, you've got to use different map titles and practice measurements and calculations. The idea is that on every map that you practice, you get better and better at the skills of interpretation as well as calculations. Remember, practice makes perfect. For today's lesson, we're going to be focusing on question 2 of Geography Paper 2. That is your map work calculations and interpretations. And to give you an overview, we're going to practice as many calculations as possible so you could be better prepared. We will focus on the following: calculating area, calculating gradient, calculating vertical exaggeration, as well as calculating magnetic declination, as well as magnetic bearing. These are the calculations that make or break you in question 2. The more you've mastered it, the better you would be performing. So let's get straight into it. The first one that we're dealing with is area. Now you will note that area is calculated in maths literacy, as well as geography. The principles are the same, but in terms of our standardized measurements, we're working with centimeters, millimeters, and kilometers, as well as meters. The 4 standard measurements that we work with in geography, again, kilometers, meters, centimeters, as well as millimeters. So, because we are using maps, we're working with scales, and we've got to ensure that these standardized measurements are scaled according to how we would want to represent them in reality. So let's look at the types of questions you will get in Geography Paper 2, question 2 from previous exams on area. Note the following. When it comes to calculating area, you should always remember scale is used to convert centimeters to kilometers. In order to do this, we multiply the distance measured on a map by 0.5. That means that on all 1:50,000 topographic maps, the scale that we use when we measure on a map in centimeters is 0.5. So let's look at some examples. When we're converting from centimeters to meters on the map, note the following. Multiply the distance measured on the map by 500. When you're working with 1:50,000 maps and you want your answer to be in meters, you've got to multiply by a scale of 500. Today's examples will show you how you use those scales and how we convert to achieve the final answer. Let's look at our first example. Note, we are working with topographical maps. The question says, calculate the area of cultivated lands, area P in block F4 on the topographical map. Now note, if it's a topographical map and your measurements are in centimeters, it's 0.5. If your measurements are in meters, yes, 500. So, show all calculations. Very important in that in geography we allocate marks for every step of the calculations. Marks will be awarded for calculations. And most importantly, you must indicate your unit of measurement in your final answer. Let's look at the very first question. The first question says, calculate the area of P. You've got to zoom into your topographical map to determine the answer by measuring with a ruler. Note, when it comes to area, we're dealing with the length and breadth. Area is equal to length and breadth, length times breadth. What you will also note is that your formulas in geography are always given to you. So it's about the application of that formula. In this particular example, note that in terms of the feature that we are using, you have a breadth and you have a length. These must be measured and applied to your formula. That was point P on the map of Falkirk. Let's look at how you lay it out. Note, there is 1 mark allocated to the measurement in centimeters. There is 1 mark allocated to the measurement in centimeters as well here. What am I doing? I am multiplying by a scale of 0.5. That simply means that my final answer must be in kilometers squared. So 1 mark for the length, 1 mark for the breadth, 1 mark for the conversion. The moment I multiply 1 centimeter by 0.5, I get to 0.5 kilometers. The moment I take my breadth measurement at 0.6 and multiply it by a scale of 0.5, 0.3 kilometers. Note, the answers in this step are in kilometers. Why? Because I've measured by 0.5. Hence, kilometers times kilometers equals kilometers squared. And my answer, 0.5 multiplied by 0.3, 0.15. That final answer is given a mark only if you have your unit of measurement. Note the marks for area. 1 mark for the length measurement, 1 mark for the breadth measurement, 1 mark for the conversion of the length, 1 mark for the conversion of the breadth, and your final answer. This is simple, guys. Area is 5 marks if you've laid out your responses so that your markers can see exactly what you've put in. Let's use another example. In this particular example, note the following: meters squared. Calculate the area of the cultivated land, area P, in block F4 on the topographical map. In this example, we are converting our answer to meters squared. Immediately you should remember I'm multiplying by a scale of 500. So note, show all calculations. Marks will be awarded for calculations. Every step gets a mark, as well as clearly indicating your unit of measurement in the final answer. Just going back to the question, note that in this particular question, we are focusing on meters squared, using the same feature as on the map of Falkirk. Always remember that your shortest side is the breadth and your longer side is the length. Upon measuring, I get the following. Again, 1 centimeter. For my length, 0.6 centimeters for my breadth. But note that in this particular example, because I want my answer in meters squared, I'm multiplying by 500. Why? Because then when I convert, my answer comes to meters. So 1 centimeter, let's do that in red, 1 centimeter multiplied by 0.5 gives me 500. 0.6 centimeters multiplied by 500 gives me 300. Meters times meters is meters squared. 500 times 30 is 150,000. Note the unit of measurement in the final answer, allocated a mark. This is straightforward, provided you are measuring accurately and using the correct scale. So, how do I remember this? When I'm using a topographical map and I want my answer in a kilometer squared, my scale is 0.5. If I want my answer in meters squared, my scale is 500. Always remember, the final answer must have a unit of measurement. Kilometers times kilometers is kilometers squared. Meters times meters is meters squared. Let's look at how the area calculation plays out on an orthophoto map. In this particular example, remember that you have to be working on the following. An orthophoto map, the scale is 1:10,000. That means that instead of working with 0,5, I'll be working with 0,1. And instead of working with 500, I'd be working with, correct, 100. It all depends on the nature of the question. Does the question require me to calculate an answer in kilometers squared or meters squared? Very important. Don't forget to read. Now, in this example, you have the following. Calculate the demarcated area 1 on the orthophoto map, in kilometers squared. Immediately, when you see kilometers squared and it's an orthophoto map, 0.1. Note, always show all calculations, because now we know that when you're showing all calculations, marks are awarded for each step. As well as we've said it, marks will be awarded for each step. Moving on, let's look at the calculation. Note, the formula will always be given. In this example, 10 centimeters was my length, 1 centimeter was my breadth. Note, I'm working to an answer in kilometers squared, and because it's an orthophoto, I am multiplying by 0,1. 10 centimeters times 0,1 is 1 kilometer, and 1 centimeter times 0,1 is 0,1 kilometers. Always note, 1 times 0,1 is 0,1. Kilometers times kilometers is kilometers squared. That means that a full 5 marks is allocated for measuring the length, measuring the breadth, converting it correctly to kilometers, as well as making sure that my final answer has a unit of measurement in kilometers squared. What do you think the last example is about? The next example on area is showing you on orthophoto how to get to meters squared. Yes, so looking at it, calculate, and immediately look at the question. It's showing you meters squared. The average area of the Pongola Aerodrome, demarcated by 9 on the orthophoto map. Standard instructions again. So we're remembering that we need to show all calculations, as well as making sure that every step is clearly indicated with a unit of measurement. Let's look at that aerodrome. You remember the map of Pongola? And as we've said, now you know the longest side is your length, the shortest side is your breadth. So in this particular example, there's my breadth, which is the shortest side, and look at the length. So I would have needed a long ruler, guys, and you must go in with your ruler and make sure your ruler is at least a 30 centimeter ruler, not the small ones you've eaten up. So, looking at it, the answer again, my formula which is given, length times breadth. When I measured the length, 10.8 centimeters. When I measured the breadth, 0,7 centimeters. Note the following. Because I'm working towards meters, I need to multiply by 100. 1080 is the answer for 10.8 times 100. 1 mark. 0,7 centimeters times 100 is 70 meters. Another mark. Remember, meters times meters, meters squared, and my final answer, 1080 times 70, 75,600. So, what have we learned? When we're calculating area, always remember, if you are calculating area on a topographical map, your scales must be either 0,5 if I want my answer to kilometers squared, or 500 if I want my answer to meters squared. When I'm working with the orthophoto map, my scale is 1:10,000. So therefore, I measure in centimeters, but if I want my answer in kilometers squared, it is 0,1. If I want my answer in meters squared, 100. Once you remember this, you put out a layout that will enable you to get the full 5 marks. Looney, I think we're off to a good start. How about you?
Thank you, Kamlan. Yes, we are. Guys, we are going to take a quick break, but please don't go anywhere, and we'll see you after this. Welcome back from the break, Matrix. If you've just joined us, we are doing your final exam prep to help you with the upcoming exam. If you're constantly running out of data, then this next competition is just for you. Wazo Matrix is bringing you the hashtag WazoWinner competition, where 2 lucky Matrix stand a chance to win 2 gigs of data. All you need to do to enter is head on over to our Facebook page, and all of the details will be there. Thank you so much, Kamlan, and over to you.
Thanks, Looney. Hi, Nicolene. And guys, remember, we are doing calculations and we're practicing on as many maps as possible for you to ensure that you've mastered these calculations before you sit for that final paper. The next calculation we're moving on to, you guessed it, gradient. Gradient deals with slopes. We are trying to determine whether that's a steep slope or a gentle slope. And to do that, we must calculate the gradient of that slope. Let's look deeper into its meaning. So, remember the following. Gradient in geography is about and concerned with the inclination, the angle of a slope, how steep or how gentle the slope is. So, always remember the exception. Due to the fact that surfaces, especially on the earth, are not uniform. When we say uniform, no surface is the same on the earth. Gradient is measured as an average. So remember, on the earth's surface, you have both steep slopes as well as gentle slopes. In order to determine the gradient of a slope, how steep or how gentle, we are actually calculating the average gradient. The average gradient gives us an idea of the type of slope we are dealing with. Now, let's get deeper into the calculation. And note the following. When we're looking at topographic maps, what is key is the spacing of the contour lines. What have you learned from primary school, grade 4 social sciences, grade 9 social sciences? The spaces between the contour lines determine whether it's a steep or gentle slope. So merely just looking at your topographic map, you will be able to determine the average gradients, whether the slopes are steep or gentle. So what should we be looking for? Always note the following. When the contour lines are close together, notice the steepness of that slope. It is a steep slope on the Earth's surface. When the contour lines are more far apart, notice the gentleness of that slope. So, when we're looking at maps, especially topographical maps, which we are viewing from the top, and we see contour lines, those contour lines are an indication of slopes. The closer those lines are together, the steeper the slope. The more far apart they are, the more gentle, or we also use the word gradual, the slope is. So, note the example. In this particular topographical map, note that this particular area to your left is containing many contour lines, and these contour lines are close together. However, as we move further to the right, note the contour lines are spaced far apart. And what does this mean? It means that in PAL, which is the map that we are dealing with, there is a steep slope represented by contour lines that are close together. Most of the development, and you'll note the following, these gray areas are your built up areas. These darker blocks are your industrial areas. Notice how the development in this particular map, let's bring in a red, is concentrated in the valley. Why is this a valley? Because on the left hand side of PAL, there is a steeper slope indicated by the contours. Notice the development of this area that is found in the valley. Also refer to the following. Remember the map of Pongola. Notice around this slope how steep the contours are. How do we know this? The contours are close together. As you move further out from the center, the contours are becoming far apart. So what does this mean? The shape of this particular feature is rounded and steep at the top, and as you move out, it becomes gentle. Yes, it's a conical hill. How do I know this? Because it's got steep sides, a pointed at top, as well as gentle slopes on the sides. So, how do we know it's a conical hill? Always remember, there's a trig beacon at the top, giving you a height, meaning that it cannot be a butte because it's not flat. It is rounded at the top because of its trig beacon. Let's get into a gradient calculation. In the 2018 November NSC, we have the following question. Calculate, and note we are using average gradient, and you will remember we calculate average gradient because slopes on the Earth's surface are not uniform, not flat. They're always undulating or uneven. Between contour line 0, which is at 820 meters, and the trig station at P on the topographic map. Standard instructions show all calculations. Marks will be awarded for calculations. Now, let's take a closer look at the map that we are dealing with and zoom into these 2 points. These 2 points are characterized as follows. Here's area P, and note in area P characterized by trig beacon 275. Note area 0, which we've been given as a height of 820 meters. For gradient, the formula is gradient is equal to the vertical interval over the horizontal equivalent. What are these? What are these variables? So, when it comes to the vertical interval, we are talking to the distance between the 2 points. And that can be calculated using a ruler, which must be calculated in meters. Why meters? Is because the heights of the other 2 points, or your horizontal equivalent, is already in meters. Looking at the calculation, it's as follows. Note, the formulas in geography are given, so you don't have to spend time memorizing the formula. This will be given to you. All you have to do is be able to apply the formula. So, your answer, we first calculate the vertical interval. And note the following. The 1 point is 1057.9 meters. I'm going to go back to the topographic map. Note the map, on the map, it's given as 1057.9. 265 is the number. Lots of you make the error of using 265 as your height. Remember, the number is always at the apex of your trig beacon, and the height is always at the bottom or the side of the trig beacon. In this example, your height is given as, correct, 1057.9. And note in the question, your point O was given as 820. Let's go back to the calculation. There's my 820 and my 1057.9. I must subtract to get the interval of the height, which is 237.9 meters. I've calculated my vertical interval. Note, for horizontal equivalent, I must measure the distance between the 2 points. I'm going to go back to the map and note the following. When I calculate that distance, it's as follows. I take my ruler and measure from point P to point O. With a ruler, I measure that distance and I get the following, 3.9 centimeters. Why am I multiplying by 500? I need an answer in meters. And as we've discussed in the calculation of area, when you're calculating a distance and you want to express it in meters, you must multiply by 500 because it's a topographical map. When I do this calculation, I get 1950 as my horizontal equivalent, my second answer. Now that I've got these two variables, I can use it in my formula. Let's pay careful attention to how your answer should be laid out. It's as follows. Note the formula, but the tick is not given to you because that is already given in your question paper. When I substitute my values, 237.9 divided by 1950 meters. Now note, I've substituted in your formula. I've got a mark for the vertical interval, I've got a mark for the horizontal equivalent. However, what you should note is that when it comes to calculating gradient, gradient must be expressed as a ratio. We are looking at, as we move up the slope, what is the relationship between how far we go and how high that slope is rising. So, if we want an answer as a ratio, we've got to take this calculation with its formula and express it as a ratio. To do that, we must do the following. To get a ratio, I must take my numerator, which in this case is 237.9, and multiply it by itself. Why do I do that? Because then I can get an answer of 1. 1950, which is my denominator, which in this case is my horizontal equivalent, must also be divided by 237.9. What I do to the numerator, I must do to the denominator. My answer is 1 over 8.2. Now this is what we call a RF scale, or a representative fraction scale. When we have a fraction scale, we can express it as a ratio. 1 over 8.2 is the same as 1 is to 8.2. What does this mean? For every 1 meter in height, I must walk a distance of 8.2 meters for the gradient to increase as much. Do we get that? 8.2 meters for a height increase of 1 meter. That means that we are dealing with an almost steep slope. Now the ratio you should be working with is 1:10. Let me note that down. The moment an answer is less than 1:10, you can consider that a steep slope. If it's greater than 1:10, 1:11, it is a gentle slope. This is a rule of thumb. So in my answer for this question, I've got 1:8.2. Hence, the gradient between these 2 points is a steep slope. How do I know that? For every 8.2 meters in horizontal elevation, the vertical interval will increase by 1 meter. That means a shorter distance. Imagine if I had to walk 100 meters. That's a longer distance to cover the height of 1 meter. Are we getting the picture of gradient? Let's do one more example. In this particular example, calculate the average gradient between 0.6 and 0.7 on the orthophoto map. Note in this example, the first example was a topographical map. Immediately, because I'm using an orthophoto map, what should I be thinking? I need an answer in meters, so that means that I must be multiplying by, you got it, 100 meters. Good. Let's look at this calculation. So here's my section of the orthophoto map, 0.6 as well as 0.7. And in this particular example, a line was drawn to help me determine the measurement much more accurately. So let's look at it. Note, your formula is always going to be given. Average gradient is equal to vertical interval over horizontal equivalent. Looking closely at my vertical interval, when I looked at the contour lines on the orthophoto, the first point, 1,400 meters. The second point, 1,220 meters. The difference between the higher height and the lower height is 180 meters. Hence, I've got my vertical interval. For my horizontal equivalent, remember I am measuring the distance between the 2 points. Multiplying by 100 because I want my answer in meters. 3.8 centimeters times 100 is equal to 380 meters. Now that I've got my two variables, I can insert them into my formula and calculate the gradient. So the average gradient is as follows. Remember, the formula is always given. Vertical interval, which I've calculated at 180 meters. The horizontal equivalent, 380 meters. And note, I need to express gradient as a ratio. That means I need to do a calculation that converts it to a fraction scale and then to a ratio scale. So, my 180 times 180 is equal to, divided by 180 is equal to 1. 380 divided by 180 is equal to 2.1. My answer, 1 over 2.1. What does this mean? When I'm expressing it as a ratio, 1 is to 2.1. So, is it greater or less than 10? Good, it's less than 10. What does this mean? It's a steep slope. How do we know this? For every 2.1 meters walked, the height of the land surface increases by 1 meter. I'm walking a shorter distance for a higher increase. The longer the distance, the more gentle the slope. The shorter the distance, the more steeper the slope. Are you getting it, guys? I hope you are, because now you know the average gradient is trying to determine whether the slope is steep or gentle, and all you need to do is work towards a ratio. Now, the next calculation that you should be focusing on is vertical exaggeration. This is standardized according to the scales that is used on your topographic map. That is 1:50,000 and an exaggerated scale depending on the construct of your cross-section. Let's look at this calculation in detail. Remember that vertical exaggeration is a scale that is used to emphasize the vertical features on an axial plane relative to the horizontal axis. That means that when I'm looking at a cross-section, that cross-section is a reduced version of reality. When I'm trying to determine the vertical exaggeration, I'm trying to determine by how much is that cross-section exaggerated from the real feature. That is what vertical exaggeration is about. When you look at a cross-section, you'll be able, by using the vertical exaggeration, to determine what the height of that particular feature is. But I think we need a break before we get into detail on vertical exaggeration. Looney, are we good?
Yes. Thank you, Kavalit. We are going to take a quick break, guys, so please don't go anywhere. We'll see you straight after this. We're back from the break, guys, and it's the final stretch of the show. I hope you're still enjoying it and you're taking as much information as you can. Thank you so much, Camlin, and over to you.
Thanks, Looney. Thanks, Nicolene. We're on to the last segment, but we've started with vertical exaggeration. So let's continue with that calculation. So note the following, that in this example, you'll always get the formula given to you. And our formula for vertical exaggeration, vertical scale over horizontal scale. It's acceptable to write Vs over Hs, but note that these formulas are given. Now, let's look at a calculation. Note that in this particular example, 1:2000 represents my vertical scale. And always your topographical maps is 1:50,000, my horizontal scale. How do I work that out? Now remember the following. I express my vertical scale as a fraction and I express my horizontal scale as a fraction. 1/2000 times 50,000 over 1. Why? Because in this particular example, when I cancel my zeros, that's 3 zeros there, 3 zeros there, that's equal to 50 over 2. Now, 50,000 times 2,000, or 50 divided by 2, is 25. What does this response mean? And note the unit of measurement is times. It means that when you're looking at your cross-section, if you exaggerate it upwards 25 times, it is the reality of that image, the real life feature. Exaggeration helps us better understand what the reality of that feature is in terms of size versus what it is like looking on a paper. So the next time you're looking at a cross section and you are asked to calculate the vertical exaggeration, know that you are trying to determine the actual reality of that feature on the Earth's surface. Now, let's move on to something which you all enjoy, magnetic bearing. Now, that is our next calculation. And remember, magnetic bearing, any bearing is the angular distance. And when it comes to magnetic bearing, we're talking about the Earth and how it is declining year on year. Let's get a better understanding of that. Always remember your formula. Magnetic bearing is equal to true bearing plus magnetic declination. Note the plus sign never changes. Why? It's a formula that is given to you. Magnetic bearing is equal to true bearing plus magnetic declination. What you should note is the following. To calculate the true bearing of your formula, you need a protractor. A protractor is used to measure angles, and these angles help us better dictate the true bearing. So, the horizontal angle between 2 points on a topographic map measured in a clockwise direction, that is the true bearing. So take note of the following. Remember that when you're using a protractor, the protractor faces to the east when the second point lies to the right of the protractor. This is determined from your question, the from point. Note how the protractor looks when it's facing eastwards, and that angle comes from your true north, as well as if the from point is placed at the center of the protractor. Remember the following. The protractor faces to the west in that direction when the point after the from point is to the west. So you would be measuring angles in a westerly direction. These are the only two directions that your protractor should face to give you angles between 0 degrees and less than 360 degrees. So the following is important. When we're looking at magnetic declination, we are looking at the Earth in terms of its position in relation to true north. Now, always remember the following, that in this particular diagram, we are trying to determine the Earth in terms of its relation to true north. The line that you see in white, which is now changing blue, is the equator. This line represents the angle at which the Earth is inclining. So your North Pole is actually declining to that way. The distance between the North Pole and the magnetic north is called your magnetic declination. So when we're calculating magnetic declination, we are trying to determine how much of an angle is between the North Pole and the north, which is according to its geographic north. So this line here represents your geographic north. This line here represents your true north. That angle is a magnetic declination. Note, in terms of the graphic that we have now, you're looking at all the prime meridians, or what we call lines of longitude. And because this diagram represents the straightened lines, all these lines of longitude meet at the North Pole as well as the South Pole. However, what do we know? Because of the Earth's inclination, note the angle. Look at where the North Pole is. It is not perfectly located to the north, when in actual fact, the north is located here. So this angle between the magnetic north here and the true north here is what we call the magnetic declination. Let's look at an example of magnetic declination from the 2019. Calculate the magnetic declination for 2019 using the information on the topographic map. Note your standard instructions, calculations, awarding of marks, and make sure that your final answer is expressed in relation to true north. So, remember that this information for magnetic declination is contained in the marginal areas of your map. You've got to find them on your map and use them in this calculation. And when you're reading, note the following. The mean magnetic declination represents the year of the map in which it is produced, which is July 2002. We're going to take 2002. Your mean annual change, 12 minutes westwards. What you should remember, when it comes to the mean annual change, if it's westwards, you add. If it's eastwards, you subtract. And of course, that year is the year of the mean annual change. Now, looking at the following. Remember that these steps, difference in years, mean annual change, and total change, is given in the examination. When you are calculating, you should note the following. When it comes to difference in years, we've got an answer of 17. How did I get that? Why? 2002. And in this case, we're using the map of 2019. Gives me a difference of 17. So I'm going to write it on the side here. That's 2019, which is this examination, minus 2002, which is the year given on the map. And that answer is 17. The mean annual change is received from the map. Let's go back to the question. The marginal information, 12 minutes westwards. And when we go there, we insert that for a mark. Note the units of measurement are included. To calculate the total change, 17 years times 12 minutes. That's 204 minutes. Always remember, if you get an answer for your total change greater than 60 years per minute, you've got to convert that to degrees and minutes. To do this, you've got to ask yourself, how many times does 60, which is 60 minutes, which is also equal to 1 degree, how many times does 60 go into my total change? In this particular example, we've got 204. So I need to ask myself, how many times does 60 minutes go into 204? I get an answer of 3, which is expressed in degrees, and 24 minutes. So 204 minutes represents 3 degrees and 24 minutes. But that's only the total change. Let's move on. Now I can calculate my magnetic declination, which in this case was 2019. Remember, I've got this from my map. Let's go back to that map. And here we go. Oof. And here we go with the magnetic declination. And there we are. So remember, your 206 is given as marginal information on the map. Now we move on to the calculation. 206, that's our mean magnetic declination as well as our total change, which we have calculated to 3 degrees and 24 minutes. And my final answer, 23 degrees, 30 minutes with my unit of measurement west of true north. However, guys, we haven't ended there. All we've done is calculate the magnetic declination. Now we need to implement it into our formula. So let's look at it. The question says, determine the magnetic bearing for 2019 from trig beacon 89 to block B9 where there's trig beacon 83. Looking at the question, note the following. On the map of Pongola, there's your 1 point, trig beacon 83, and there's your other point. My true north is as follows. Remember, when I calculated true bearing, it was 57 degrees. No matter what angle you're getting, note that you're going to add it to your magnetic declination. My magnetic declination, which I've just calculated at 23 degrees and 30 minutes west of true north. Let's apply it to the formula. Writing down my formula, but note this will always be given. My true bearing, 57 degrees. My magnetic declination, 23 degrees and 30 minutes west. And my final answer, 80 degrees, or 080, as they would say in aviation. And with that, remember the following. Indicate the units of measurement in your final answer. Always marks are allocated for this. You must have the following equipment: a calculator, a ruler and a pencil, protractor, as well as eraser. Some tips for you: write neatly and legibly always. Ensure that the layout of your responses is aligned to the question paper, and begin each exam by orienteering your topographical map as well as your aerial photograph. Take the time at the beginning of the exam to familiarize yourself with the different features on your topographical map and match them to the photograph. With that, remember guys, map work, geographical skills and techniques is where you're going to pass geography. Good luck with your exams, and that's back to you, Looney.
Thank you, Cameron. Matrix, I hope you guys enjoyed the show. Please don't forget to use all of our resources that are available for you guys to study and help you prepare. Congratulations to all of our competition winners who will be announced on Facebook after the show. Don't forget to check out our schedule on www.wasamatrix.co.za, and if you missed any of our lessons, they are available on our YouTube channel. Thank you so much guys from me, Looney, Cameron and Nicolene. Goodbye.
Wasamatrix 2021 Catch-Up is brought to you by the Department of Basic Education, NECT, ETDP SETA, SABC, MultiChoice, and DBE TV on OpenView Channel 122 in partnership with